if that helps. Are you able to see the stream? Maybe it'll take a second or two to get there. Hello everyone, we're just trying to get the stream up and running. Yeah. Alright, let me know if you can see the stream now. It should have been updated.
Yes, sir. I can see and I'm on.
Okay.
And I can hear. I'm pretty sure I'm hearing Sir's live voice right now. Oh, I can hear myself also.
Okay, excellent. So I'm going to turn my microphone off, and will be just the stream audio or the mic. Okay, cool. Let me just maybe share, or if one of you wouldn't mind sharing the link to the stream, I would appreciate that. Just share it in the WhatsApp group. All right, so I should be able to see your chats, both in the Google Meet as well as the YouTube chat. So let me just say. All right, we can probably get started. We'll wait another 5 minutes as usual, and then we can get started, wait for everyone to come in. Yeah. Are there any questions before we start?
Send the link now, sir.
Excellent, thank you. Yeah, there is a bit of a delay, so we'll see how the delay is with the stream. Okay, we'll give people another minute or so, and then we'll get started. Today's lecture is going to be, again, just some file reading, maybe a bit of file writing, and then we're going to look at exceptions. We'll see how far we get. I don't, obviously I don't want to give you too much to work with at once, so we might stop a bit earlier before finishing exceptions, and then tomorrow we'll probably do a demo with some exception handling, file reading, file writing, just to kind of cap everything off, and we'll maybe do some multi-dimensional arrays depending. Right, so give it another minute, we'll get started. Yeah. I'm not sure how we'll do with copyright, but maybe in the future we can have a playlist, and you guys can suggest songs that you would enjoy listening to. All right. As always, feel free to ask questions in the chat. If you want to ask questions via voice chat, you're also welcome to do so. Just go to the Google Meet, join there. There might be a delay with you asking questions via Google Meet, me giving you answers depending on the stream delay, but we'll try to work with it as best as we can. Without further ado, let's jump into yet another lecture for COS101 for term 4, working with Java, working with files. Yesterday, we did some basic file reading. Today, we're going to do a little bit more involved file reading. We're going to look at how the scanner, a little bit of the internals of how the scanner works, how we can change the scanner settings to give us a slightly bit different behavior. Up until this point, we've been working with kind of raw text files, kind of just data, we'll read integers, whatever. We kind of structured them in our own way, but we'll look at a very common file format today called a CSV, or a comma separated value file. So if everyone's ready and if there are no questions before we begin, we'll get started. As always, these lectures are going to be recorded. The reason why we moved to YouTube is that we can have them uploaded and live a lot sooner, so that the processing happens quicker, and also so that we can then embed those into the lessons tab on eCanva. I'll look at downloading the videos as well and then re-uploading them to the eCanva page if that'll work better. But otherwise, I think this might be a good system. As always, I appreciate your feedback. So let's have a look at the following data file. A CSV file is a very common data exchange format file. So,
Sir,
yes.
I just say that I think this method does work quite well.
Yes.
Your YouTube method. But then I think sir might just have to I guess say on the name like week 1 or week 2, but I guess everything else is fine.
Yep, we can edit the file names afterwards. What might work best is if you guys are talking, just mute the stream, and then we won't get feedback. But yeah, we can definitely. I'll put week 1, lecture 2, lecture 3 as we go forward. So thank you for the feedback. Okay, so CSV files are very common for exchanging data. Very common in terms of science, finance, everything, right? If you are, at a bank and you want to download kind of your bank statements or your transaction history, you can do that into a CSV file, so it's very common. So we're going to look at it, and we have something very simple, just a couple of values separated by commas, and we're going to see how we can read these values.
So what's the difference between a CSV file and a TXT file?
So it's just the extension, but the extension tells us what the format is. So we know that the file extension, so all files, the file name doesn't matter, the extension doesn't really matter, it only matters how the data is structured, but we use the file extensions to give us a hint as to how the data is structured. So with a CSV file, it stands for comma separated values, and so the comma separated values are exactly what they are, right? But it's typically in plain text, just like you see, right? Human readable format, but it's a bit easier to read because we know that everything is separated by a comma, so there is a good idea of what the format of all the data is. So that's the only difference. It's actually a text file, but it has a different extension and it has a specific way that all the data is laid out. So you can see over here, we just have a random data.csv. As always, this will be, these files and the code samples will be uploaded to eCanva into the resources, and I'll make sure to include it as part of the lessons tab. I had to figure out how to do that. So because our data, whether or not we labeled it a TXT, we can read this data as a CSV because every value that we want is separated. So to do this, we can use something special. We can either read the entire line and then go through line by line, and at every point we reach a comma, we have some sort of if statement, or we try to match the character and then we put those together and parse a int or whatever. Very complicated, kind of roundabout way. Instead, there's a much easier method where we use a delimiter. Now, a delimiter is just saying this is a separator between two tokens or two items that we're looking at. So with the scanner typically breaks things up into something called tokens. And so when you call the has next or next method in a scanner, it looks at a token. And typically these tokens are separated by a character called the delimiter. And usually this delimiter is set to be white space, either with a line, like a new line, or a tab, or a space character, right? But now, because we know our comma separated value data is delimited by a comma, we can change it. So scanner has a method called useDelimiter. And when we call useDelimiter, we can specify a new separation. Okay, so if this were just a txt file, we might just have, instead of a comma, a space. And that's perhaps how a lot of you did it for test 1. However, when we want to read kind of different file formats, they might use different delimiters, and so this is why it's useful. Now, if we set the delimiter as a comma, then every time we call hasNext, it will move to look ahead and see what is past the next comma. And if there is something, it'll say hasNext is true. If there isn't anything, it'll say hasNext is false. Okay, so instead of spaces, we're now looking from comma to comma to comma. Okay, so we have a file called the CSV printer, and it's a class that we created. We have our classic, our default public static void main string. And remember, yesterday we looked at using program arguments to specify files on the fly. So that over here, this little / ellipses, that's just that code where we load a file from, we create a file to print from the arguments, or however you want to do it. We create a new scanner that we call CSV reader using the new keyword. Remember the new keyword for object-oriented programming next week. And then we say CSV reader.useDelimiter. Okay, so we're setting the internal configuration of the scanner object that we've created. We're saying, okay, create a default scanner, but we want to change some of the settings in the scanner. Okay, and that's what useDelimiter does. We're setting an internal setting of the scanner to be a comma. So now the scanner will go through, and as it's reading the file, it will look for a comma, and it will break up the contents of the file according to the commas. In Python, you had the string.split function, right, where you could give it some pattern to split a string with. This works in a similar way. So it's based on a similar principle. We just make sure, okay, so we have no questions in the chat, that's fine. I'm just going to make sure we go back and forth between the chats and everything. So the Python string.split function functions in or works in a lot of the same ways. So you have some sort of string, and typically our files that we're using, we have this idea of their text, their sentences, strings, and then we want to split it up and move through each item with the hasNext while loop. So you can see everything else looks pretty standard as to just reading a normal set of values. We're still using our scanner.next to print something out, and then we're using our scanner from a file. So everything else is the same. We've just changed the delimiter, and we've given it a CSV file. As usual, because we're working with files, we need to be sure we're catching a file not found exception, right? So in case we can't create the scanner from the file, then there's a file not found exception. And to be safe, we make sure to close the file once we're done reading from it. So what does this yield? What does this give us? Well, if we run this code and we give it this data.csv, we will see the following. Over here, we'll see all the digits, all the data values have been printed out, one line each, and the comma, the delimiter, has been removed from the output. This is because the delimiter is not viewed as a part of what the scanner wants to use. The delimiter is just used to separate items that it wants to work with. Okay, so the delimiter is never actually part of what we want to read or scan. Does that make sense to everyone? Okay. Just make sure. I think everyone...
Yeah, yes.
Okay, everyone's okay with that. Good. So, does that example make sense, how you might read a CSV file? Should I show you a demo before we move on? Okay, you know what? Let's look at the CSV reader or CSV printer. So we have this code over here. Same as before and same as yesterday. We have a arg0 as our file that we take in. So we take a path to a file. We have a file to print that we create with a file name or the file path. We create our CSV reader. We also have an item counter. So we've just beefed it up, added a little bit of extra source in there. So while it has a next item, so delimited by a comma while it has a next item, we increment the item counter and then we print out this is item number and whatever we read, right? So this says dot next, right? And then we close and we run the program. So now if we compile csvprinter.java, the compiler didn't tell us any errors, so we're good to try and run the program. I think you did a bit of error types in programming. So a runtime error versus a logic error versus, right? So in this case, we have no compile time error. So an error that is present at compile time, which might be a syntax error or a grammar error, right? So then we can say, we can have a look at the data.csv. And it's exactly like what we had before. So if we call Java CSV printer and we give it as an argument data.csv, right? So this argument is argument number 0, right? So we've added an argument. We run it and we can see that it's printed out all of the items, right? Now, beware, you might say, why is it not starting from 0? That's because we increment item counter before we print it out. Okay, so just in case you were wondering, this is just because we try to make it a bit more human-friendly, human-readable friendly. Is everyone okay with that example? Everyone with me about how it works? Okay. So I think you're all good. Okay, excellent. So I think we can move on. Let me just move back to this. All right, so now that we are able to read files, we can also try to write to files. And I think you've done some file writing before. Just let me know if you haven't, then we might dive into it a bit deeper. But writing to files is actually a bit easier than reading from files. One of the main differences in writing files, and you might have done this in Python, is there might be a different mode, right? So when you write to a file, you either overwrite, so you create a new file from scratch in the event that the file already exists, or you append to a file, so you keep adding data to the end of a file, right? That's one of the big concerns, and that might raise an exception. So instead of a file not being found, when we write to files, we can create new files. However, if we're going to overwrite data and that file has been secured for some reason, it's not possible to write to that file, we might run into certain exceptions, right? These are all kind of methods that evolved out of just being a bit more secure with data and not causing data corruption. So, writing to a file, same as with reading to a file, we just create a new file object, which is the java.io.file class. Then we have some sort of data, which is typically as a string, although we can print other data types to a file as well by converting them into a string. Then we create something called a file writer object. Okay, so when we create a file writer, you can think of this as kind of a reverse scanner. Instead of reading values from a file, it's putting values in. So we create it much in the same way we would a scanner with the new keyword and giving it the file object, right, with our data. Then we say file writer.write your data. And it's important to know here that it's not like printing, where you can say print or print line. If you want a new line in your file, you will have to add a new line. So you'll need to add like a \n to your data. And then we say close. Again, as always, we want to be safe and make sure that our files are closed when we're not using them or we don't need to use them. And that's about it. Okay, pretty straightforward. You can just output a bunch of data to a file. Now, where this might be useful, you'll be asking, is in a very real-world application, you can write logging data or debug data. So instead, when you're running your programs, instead of printing a bunch of stuff to the terminal and cluttering up the terminal with unnecessary debug data, you can open a log file and you can just write your data to the log file. And then later, once the program's finished executing, or maybe once the program's crashed, you can go after the fact and read the log files. Okay, so it's a really cool application. You guys are you're all now well equipped enough, and your toolbox is well equipped enough to be able to do some really cool programming things and really cool systems design use cases. Okay, so writing log files is very cool, and a lot of very high-class software require extensive log files in case of software auditing and making sure data corruption doesn't happen. Or if it's like a remote server software, you'll want to write log files because you might not immediately have access to them or immediately have access to the terminal, but you might want to, remotely log in and then read what's been happening in the log files. In fact, I can show you an example. On Linux, we have a system log file called the journal. So if I say journalctl.exe, these are all the events that are happening in my system, and you can see there are about 2,100 log lines. So this is the system log file that's happening. It's just giving me the last page, but we can scroll up, and you can see this rkit daemon is giving me a bunch of threads to supervise, and then if we go up a bit, you can see there's a bunch of, so the ocular UI is unable to do something. So the log files are really cool. And now that you can write to files, you can create your own log files. Are there any questions about writing to a file? Okay, I'm trusting you to post some things in the chat or to speak up during the Google Meet. Otherwise, I'm going to keep going forward. And I want to give you time to ask questions as need be. Is everyone still with me? Everyone's still okay?
Yes, sir. So far, so good.
Excellent. Thank you. All right. So up until now, we've been using something called unbuffered input-output, or unbuffered I/O. And what unbuffered I/O means is that when we are reading or writing to a file, we are stuck reading and writing to a file until we are done doing the reading or the writing. This is bad because file reading and writing blocks a lot of the thread, so the process thread for a program. So on the CPU, you might have like different road lanes, different highway lanes where you can execute called threads. And the file I/O is essentially like a big freight or logistics truck. It just kind of sits in that lane and no one can actually pass the truck until it has done what it needs to do, until it goes onto the off ramp and you're free to travel at a higher speed. So we typically, when we're reading large files, we want to use buffered I/O. And what buffered I/O says is when you have free time, keep loading from disk or keep loading the input and output, right? So when we use buffered I/O, we are kind of delegating that processing time to whenever the CPU has some free time to do it. Okay, and Java has a couple of libraries or a couple of classes to help you do that. These classes are called a buffered reader and a buffered writer. They're not as straightforward to use as the scanner or the file writer, so I'm not going to go into them at depth. I leave these to you to kind of do in your own time and have a look at, because they're not critical right now, but it's good for you to know that these exist and that these alternatives are available to you. What they do is they basically help you, they wrap around the file process and the reading and the output, that, you know, they wrap around it and they buffer the input and the output. They kind of help you do that process in a more safe and efficient way. However, this could mean that file I/O is not done when you're trying to access the file again. So if you're really quickly opening and closing files and trying to read from them at high speed, then buffered file I/O is not for you, okay? Because it's kind of delegating the reading and writing of files to whenever there's time, and it's not saying I will do it right now. Okay, so that's the important distinction. If you need to process things, say like video game files, right? We might need textures or music or whatever. We don't want to use buffered file reading because we need to access them right away. Anything with like high speed or file demand that is critical, you don't want to buffer. However, things like a really big Word document or a book where you're not going to read the entire book at once, buffered reading is a good way to do it. Okay, so with this, you will actually use the java.nio. So it's new IO, I think, is the idea. Java.nio.file.files class. And it's got a bunch of the buffered readers, buffered writers, read and write to it. Okay. The important thing to know, if you look in the documentation, I've included links at the end of the lecture. They use paths and something called char sets, so character sets. So the file encoding and everything comes into play. When you use that, that's also why we're ignoring it for now, but you're free to go look at it yourself when you have the time. So I think with that, we should be okay to move on from files and start looking at testing. Just a general idea, how have you been testing your code for assignments or just general so far? So when you did Python, how have you been testing your code?
So do you mean like in our IDE? Like,
Yeah, in your IDE.
I just use what you call it, IntelliJ.
Yeah.
And then I click run on there. Whenever there's a problem, I look at the terminal and look for the
Okay.
problems.
Yeah, that's good. Do you also sometimes print out statements?
What do you mean print out statements? Like normal printing out stuff?
Yeah, just
like
just
hello,
printing stuff out,
like that.
yeah. Yeah, just printing.
Yes, I do that.
Yeah, okay. So that is probably...
Yeah, so I actually do that to
Yeah.
check if the value is correct or not.
Okay, yeah. So I want to tell everyone, don't feel shy, because doing that is something that, probably 98% of all programmers do. So the real debugging is probably just printing things out and seeing what it is. And then the next step is probably using a debugger or logging. But we'll talk about it, right? So up until now, we've been pretty optimistic about our programs, right? Before, we didn't even do exceptions. We've assumed that if it compiles, everything will work as intended, which is a little bit foolish. Okay, so one of my favorite quotes is this one: if debugging is the process of removing software bugs, then programming is the process of putting them in. Okay, so the basic mental framework, and something you might have already come across yourself, is that you should kind of try to think about what should happen when things go wrong. So being proactive about it, right? We want to think about what could possibly go wrong, where can data get corrupted, what are our types doing, and this is all an intuition you will build over time. The more experienced you are with programming, the more experienced you are with the language and the problem you're trying to solve, you'll get a better intuition for this. Then a next best case is to actually be further proactive, and instead of just trying to think about it, we try to handle those problematic cases, edge cases, things where values aren't working, and we try to anticipate them and implement safeguards. So before, when we were using program arguments, we kind of just said, okay, they'll always give us, argument 0. And then we said, okay, well, there's a possibility that we might not get any arguments. And then we put in a safeguard, right? So this is kind of our thinking. This is what we're doing. Then we want to test code. So there's kind of correct inputs and incorrect inputs, and we kind of like see what our code is doing through giving it test sets. And then we think about edge cases. And edge cases are kind of the weird things that happen at the extremes of our values, things that we might not catch, or special and unique outlying conditions. So when we try to do something illegal in a programming language, especially Java, the code crashes or does not compile, and then we get an error message. And this is great. It's helpful, as opposed to not getting any error message whatsoever, or the code just continues running in an illegal state, or in a state that we don't want it to. So it's operating abnormally. Okay. And for as long as people have been programming computers, we've been getting errors and we've been crashing programs. So there are a bunch of syntax errors, or types of errors that you've learned about, hopefully, in Python: syntax, logic, runtime. And I'm introducing a new one to you, which is the compile time error. The compile time error is when you try to compile your program before running it, or if you're using an IDE like IntelliJ, when you try to run the program and it tells you there's an error and it can't run, that's compile time error. Okay. So the question here is, when will syntax errors show up for Java? Does anyone want to hazard a guess? Okay, so syntax errors, yes?
I would like to guess that the main class has a syntax error.
Okay, so when we compile, we'll get syntax errors. If we have syntax errors, right? But yes, it is true. So if your main function has a syntax error,
Yes.
when you try to compile, you'll get a syntax error. So correct answer. Also, any answer here is correct, with the asterisk that we need to explain why it's correct. We'll find a reason why it's correct. Okay. So the other method of testing that's more rigorous and formal, and when you go into industry, or if you're working on a large project with a bunch of people, is something called unit testing. So unit testing is a more formal process where we test individual kind of methods and pieces of the code rigorously, and kind of try to verify that it's performing as expected. And the idea behind unit testing is that if all units of our code pass tests, then we are good to go, or then the whole program should work as expected. On top of that, the next extension of that would be then something called integration testing, where we put the modules together and we see if they can work with each other. There, I've left a link at the end about software testing frameworks and methodologies. If you want to read, it's further reading. It's optional. I'm just giving you kind of a feel for what is out there if you're curious and want to go and look at it yourself. For now, though, we're just going to look about bug hunting. Okay, so number 2 here, you said you sometimes print out the values of variables, and that is a valid and quite efficient way of trying to hunt down bugs. You can also use a debugger. So if your IDE like IntelliJ comes with a debugger, you can set breakpoints. You can step through and see what the states, the values are of different variables in the memory. You can use something called the trace table. You can use something called exception handling, which we're looking at now. And then you can look at something called logging, which we discussed a little bit earlier, where we write log files and we see what's going on. Okay. All big operating systems definitely have a logging system. I think on Windows, it might be the registry. I'm not 100% sure, but you can actually get software that lets you look at the Windows logs. On Mac and on Linux, you can read the journal, which is also your logging framework. And typically, we talk about like log levels, so debug, information, warning, and so on. For this, we are only looking at exception handling. Okay. Using a debugger and using print statements, using a debugger we can maybe talk about on Friday, but using print statements and trace tables, these are all things you should be able to do relatively easily. And if you want to implement logging, that's for you to do. I would recommend it if you're trying to do any sort of big project. So situations that are beyond the normal or expected operation of the program occur quite frequently. Okay, one in a million events happen every 5 seconds. So we want to be sure that when we reach an exception, we are made aware that this is an occurrence of an unusual event, right? An exceptional event, but not exceptional in the good sense, exceptional in the bad sense. When an exception occurs, it is called throwing an exception. A good way to think about this is if you're unhappy with the state of affairs, you will throw a tantrum. So you throw an exception. And when we write code to deal with a weird situation, we are handling the exception. So we are getting a grip on the throw an exception. You can kind of think about the try catch, right? You will throw an exception and then you'll catch the exception and do something about it. We are handling the exception. Okay, so let's just have a look at the following, right? If we have a program that wants to take in 2 numbers and returns the one divided by the other, right? Pretty easy to do. Create a scanner, give a prompt, and then read 2 integers. Okay, so what happens if we give it the numbers 1 and a? Anyone want to hazard a guess? You might have run into this. Yes.
It's going to give an error, but it's basically explaining what's a try and catch.
Yes. Yeah. So if the scanner is expecting an integer and it can't find an integer and it finds a character or whatever instead, there'll be an exception that the type is a mismatch or that there's something wrong, right? It's an unusual event. We asked for 2 integers. We got an integer and a character.
Since there's no try and catch, it'll just say there's an error, but if you input the try and catch, then it'll print out saying that there's an exception.
Exactly. Yes. So that's a really good answer, and you're on the ball. So that's very good. We will throw an exception possibly at one of these 2 lines because we can give the wrong input at any time, right? An input mismatch. So the next possible exception can occur here. Does anyone want to try and guess what this exception on this line, what might occur? Okay, we're running a bit low on time, so I'll just tell you, if the bottom integer is 0, that is illegal in mathematics, and you will get put in mathematics jail. So there's an arithmetic exception that can occur whenever we're dividing one number by another number. So with an arithmetic exception, this can also happen over here. So we might want to catch multiple exceptions. So when we run the program, we can just give it 15 and 3, and it will give us 5, which is fine. We might think it's fine. If we enter 0, we will get a nice explanation that it's a divide by 0 exception. So java.lang.arithmetic exception divide by 0. So the compiler is helping us out. In this case, because we did not catch the exception, Java caught it for us. The Java runtime caught it for us, and it panicked. It crashed our program. Okay, but maybe we want to educate the user and give them another attempt. Then we will want to catch that exception. So we can throw our own exceptions as well, and then handle them when they arise. So we do this with the same try-catch block. We try to do something risky, like asking a user for a sane input. If we detect that something might happen bad, something bad might happen, we can throw a new exception, and then we can catch the thrown exception and handle it. Okay. The reason why we might do this is because at runtime, we don't know what these two numbers are. Okay. We don't know what these two numbers are. The user is supplying them. So even though our code might be correct, and we do get 2 integers, we might get an arithmetic exception over here. So to do this, we can do the following. We can try and read these in. So if you really wanted to be persnickety about it, you would have another try-catch block just over here for an input mismatch exception. However, we're just doing the divide by 0 exception at the moment. And so we say if the bottom value is 0, we throw a new exception, cannot divide by 0. Okay, so we can actually throw our own exceptions at any given time. And it's quite cool that we can do this. So if you don't want to handle it personally, or maybe someone else has to handle it, in this case it will be the Java runtime, we can just throw a new exception. So after this, we just continue. We say the answer is the top divided by the bottom. And what this means is if we throw this exception, we will have to handle it or the program will crash. And so we can trust that if this exception is not thrown, then we will get a legitimate division. Then over here, we catch the exception that we've just thrown, and we just print out its message. We don't actually do anything about it. Okay. So if you throw an exception, you don't necessarily have to have a try-catch block to throw an exception. We're just doing that for this example. But if you throw an exception and it's not caught, your program will crash. Okay. And here we're just actually printing out the message. We're not letting the exception get out of hand and crash our program. We're handling it. All right. Remember that after a catch block, Java assumes that everything's okay. So is everyone still doing okay? We have about 15 minutes left, but we can obviously review this tomorrow. I understand that I'm bombarding you with quite a bit of information here. Okay. So let's wrap this up, and then tomorrow we can just review this quickly and maybe do some demonstrations, and then on Friday will be a Q&A session. So our try-catch syntax looks like this. Try some risky code, catch a possible exception that might occur in here. We can have multiple catch blocks with multiple different types of exceptions. This catch block, specifically with the exception method, will catch any exception that occurs. Okay, so if this is first, it's a bit like a switch statement. It's the default.
So you basically just put your normal code in the try section, and then for all the errors you put in the catch
Yes.
part catches all your errors.
Yes. So the way you choose to structure your try catch blocks is a bit of a matter of taste and a matter of style, but I like to break it up into the sections of risky code that might produce certain errors. That's just my style. You're welcome to put everything in a single giant try catch block. It's up to you. This here will catch any exception. It'll match any exception, file not found, arithmetic, input mismatch. It'll catch any exception, right? And this is to do with the concept of polymorphism that we'll touch on later in object-oriented programming. So over here, when we throw an exception, we can get the exception object that we created with the new, right? So this exception object will be called E in this code block, and we can print out the message. All right. So some rules about catching exceptions. Don't worry, these slides will be uploaded. We're going to just review this quickly in tomorrow's lecture. You can have multiple catch blocks, multiple try catch blocks, depending on how you want. Handling an IO exception is different from an arithmetic exception, right? So you might want to do something different, so differentiate them. Exceptions are objects, something we'll look at next week. We use the new keyword, just like with a scanner or a string, create a new exception. They can be created and thrown separately, so you maybe want to have different exceptions for different things with different messages. And then we can make our own exception types. Okay, so this is later on in object-oriented programming. So I'm going to upload the exceptional.java code sample as well. Have a look at it. That's this file over here. Okay, have a look at it. Try to change the answer from int to double and see what happens. Some general questions to think about is what kind of type of exceptions exist. Have a look at the documentation and see which classes are subclasses of the exception class. And which exceptions do you think would be the most common? Kind of in the general scheme of Java programs all over the world, which exception do you think exists the most often? Finally, this is very cool. This is the actual CSV format specification. So have a look at this link. It shows the Internet Standards request for comment document for CSVs. This is just a little Wikipedia page on CSVs. These are the documentation files for both the file writer and the buffered IO. And then we have the exception documents. So I found that these, go and have a look at the documentation here and look at what are all the subclasses of exceptions. This gives you a pretty good overview of tutorial of what types of exceptions you get in Java. And then there's the software testing methodologies. All right, so with that, we've covered everything we need for files and exceptions. Obviously, tomorrow we'll recap everything and we'll do some demos and explore a little bit. We might even touch on the Java debugger and have a look at kind of cool stuff that you can do with Java once it's compiled a program. So I'll open the floor for any questions. Otherwise, you're welcome to enjoy the rest of your afternoon. This lecture will be processed and then uploaded to Canva as well. But that's it. So I'll open up the floor to any questions. So feel free to ask. And we could probably put the music back on. So yeah, thank you everyone. Thank you for attending this lecture.
Thank you, sir. See you tomorrow.
Yes, see you all tomorrow. Enjoy the rest of your afternoon. Drink some water, relax a bit. Try to enjoy some nice afternoon sunshine if you can.
Thank you for the session. Goodbye, sir.
Goodbye. Enjoy your day. Alright, everyone. Take care. I'll see you tomorrow.